Hi there. My name is Chris Jefferson. I'm the co-founder and CTO for Advo, and today I'm going to be taking you through integrating AI safety and looking at failure modes and how you can use that within your DevSecOps pipelines. So just to give you sort of a bit of an introduction about myself and Advi. So what we actually focus on as a company is we look at understanding AI failures. And so one of the key areas that we work within with the industry is actually how are you able to measure, how are you able to evaluate, and how are you able to enable the AI models and systems that you want to deploy. And using some of that background, that's what I'm going to take you through today in terms of some of the key points for today's talk. So I'm going to take you through some of the opportunities and challenges related to what we're seeing with the adoption of AI and why it's important, some of the key failures that you could come across, and then we're going to go run through some of the key points between the differences within the frameworks for DevSecOps and MLOps, but also a bit of an example of how you can start to take that knowledge and integrate that into your CI/CD processes. So hopefully that will translate to a few things you can take away, a bit more understanding around AI and your AI use cases, how to benefit from things such as model registries, and also how you can actually start to leverage all this within your CI/CD pipelines. So before we go any further, I just think it's useful to take you through what I mean by an AI system. So there's a lot of different things that we see around the definitions of AI, and AI can be across lots of different things. It can be, in its broadest sense, referring to statistics, but also it could actually be related to some of the more foundational models that you see today, related to the transformer technology behind the likes of OpenAI or Anthropic. And so AI in its broadest terms, it can cover machine learning, it can cover reinforcement learning, it can cover deep learning. All of these are aspects of AI. And when we talk about how we integrate AI into a usable process, this is where we come across AI systems. And one of the most useful definitions I can give to you for this is related to the OECD. And the reason it's a useful definition is because it forms the foundation of a lot of the work that you'll see within the EU AI Act. You'll see it coming across in standards and regulations, and a lot of these definitions are agreed internationally. And when we talk about an AI system, what we're looking at is a model that can receive an input from sensors or an interface, do some form of calculation and produce an output or an inference, which can then be either on that information or it can be a generation of new information. And so fundamentally, when we're talking about AI systems, we're talking about the inputs and the outputs that are generated by these models. And the reason that's important is because that translates to how we need to think about how we both look at the security of AI, but also how we do the testing of these models once they're integrated into not just a system or a service or endpoint, but also the automation and the life cycle that we need to be able to have around these models and also our infrastructure and services to be able to deploy that and use that in a more scalable way. So let me just dig into some of the importance around sort of AI. So within the next 5 to 10 years, it's going to be quite a transformative technology. It's already seen a lot go on in the last 5 years. And what we're probably going to see is that this is going to contribute trillions to the global economy in terms of the change and the impact it will have, not just on the way that businesses work, but the scale and the efficiency with which they work as well. And this can translate to the adoption of new AI use cases. This is the opening up of new business opportunities. But also quite fundamentally, it's a change to how the workforce, how people working with AI systems can be operating, and the opportunity by which they are freed up to do different tasks. And so across the different range of statistics, you can see a lot of sort of focus in terms of how with AI systems and the potential of AI, it's actually going to be a very transformative technology. And we see this within different countries. We see this within different adoptions with AI. There's a lot of scope for anticipation and hope for how these new technologies can be deployed within enterprises specifically, not only to solve traditional business problems, but to solve new problems that are seeking solutions and still need to be served and found in market. And generally speaking, there is an increase not only in the exploration of different AI use cases, but also the deployment. And I think what's been happening very much over the last year is there's been an acceleration from what has been optimistic exploration into starting to found the the groundwork by which you can actually deploy these systems and start to use them as a useful use case. And just a useful quote that I can sort of bring by you is related to Andrew NG, who's sort of one of the leaders within the AI community. But one of the key things that he points out is that people that will be using AI within the future are going to be the ones that are going to be doing the work going forwards. And that's because AI is a huge enabler. It's got the opportunity to streamline the workflows that you're working with. It can optimize how you're processing data. It acts as a useful assistant by which you're able to improve the development work or the summarization of key tasks that you're working on. And this is only going to improve with time as we see changes within not just traditional models, but also the approaches related to agentic AI, which is where there's highly autonomous, highly specialized agents, which are able to complete complex tasks as a process. So what are some of the challenges around AI integration? Well, one of the first things that you'll see is actually related to how we have a different set of dependencies that come along with AI systems, AI models, and fundamentally their requirement for specialized technologies. And so I'm talking about the frameworks that sit behind these models, but also the requirement for dedicated hardware. And when you're talking about the hardware, this is a huge challenge when it comes to the actual training of these models, because it can present a huge cost, but it can also be a challenge to how you manage to deploy these. And so you can support this in similar ways as you would with infrastructure as code. You can have access to cloud resources, but this does introduce a unique sort of cost proposition that can come along with this. And then the final piece, and probably one of the biggest and most important challenges, is related to data. Data with AI is actually particularly challenging due to the fact that you will see it being used for inference by which you can create useful next steps. But one of the other challenges around it is how it's being used for generation of new information. And this poses a new challenge, not just around how data is consumed and stored for retraining, but then also how data is returned to customers, how they use that to make decisions, and ultimately what that means for the organization that's serving the AI, that's serving that data. The next challenge is really around how do you test AI? Now, when you're looking at specifically neural networks, deep learning architectures, transformer models, you're dealing with probabilistic systems. They're not causal by nature. They do have consistent patterns, but they will not always behave in the same way. And one of the challenges when you're coming to testing AI, and especially when you're trying to integrate it into how you deploy autonomously, is how do you control for the variety within the outputs, the way that it's performing in its day-to-day tasks, the way that it can suddenly potentially hallucinate or produce outputs which you've never seen, or it's never dealt with data that way. And so one of the key strategies that you need to think about is, for the use case that I'm deploying my AI for, what are the possible failure modes? And also what are the possible ways that I can look to constrain and test that range of probabilistic outcomes? And so this then leads into sort of the next piece, which is AI comes along with all these other dependencies as well. They come from model versioning. They come from the requirements for how you can do the different iterations of the data sets, how you look at the performance statistics. And all of this feeds into not just the requirement for managing and versioning AI, but also the requirements for how you collect that information for future regulatory needs. So ultimately, the risks that we see with the AI integration, it comes from data, but it also comes from how models trained on that data will behave in different ways. And so when we look at this, we're thinking about how are these models going to fail? And so you can see a variety of different failure modes within AI systems. And so one of these that you can look at is related to data-driven failures, where the model is not dealing with information that it's used to in its training data. And as a result of that specific failure, what that will do is that pulls through lots of inaccurate outputs. And within that, you need to be able to have a robust validation strategy by which you're able to check the model for range of outputs. You're able to understand its bias. And this subsequently leads across to other aspects of data failures, such as model drift. And within that, you're looking at how the model will change over time. The world changes around the model may not. And so you need to understand that as the world of data changes, or as the model retrains, is it drifting in different types of performance and behavior? And so this can pose different challenges related to either security threats. It can pose additional kind of operational output challenges. But ultimately with this, one of the key strategies that you need to look at is continuous monitoring of those outputs and the outputs that they're producing for other systems. Now, one of the more interesting areas where you can actually look at failures with an AI is related to adversarial attacks. And this is very nuanced because it looks at malicious data inputs. And these are inputs which are designed to evade or invoke certain actions from the models. And these not only pose security risks, as we saw above, but they also pose challenging compliance issues. And when we're trying to deal with the potential for breaches of information, loss and theft of model architectures or training data, you really need to have a robust and serious adversarial training strategy in place, which you can automate to understand how all these models behave under this particular stress and this particular risk. And that also passes through in terms of sort of how we're looking at if you're trying to integrate these models and you're trying to deploy them at scale, there are the knock-on challenges of that. If they are passing and releasing too much information from the outputs that they're producing, you're going to start to see these added risks related to data leakage. And again, this is an integration challenge. How do we choose what sort of information and the types of structures of information that we allow our models to respond with? So what we'll do in the next scenarios, we'll pull through some of the frameworks and we'll actually have a look at specifically the adversarial testing pieces and some of the integration testing. And so one of the things I just want to highlight is that the different frameworks that we work with regards to, say, DevSecOps, they have their different strengths. And so DevSecOps, some of the key strengths that it focuses on is its ability to do autonomous security testing. It can look at the dependencies. You can build up your supply bill of materials from there and understand your exposure to CVEs. And this works at the code level and does a very good job at looking at sort of all of that dependency based on your code. Whereas when you're looking at MLOps, this is actually incredibly good at understanding the performance of the models, the versions that you've managed to pull through, how they're actually managing to deal with sort of different iterations of the data sets that they've been trained on, and how they actually control in terms of the performance that they see when they're deployed. And so what we actually tend to see when we're talking about this integration of MLOps, sort of model management and sort of traditional DevSecOps deployment is there's this almost aggregation of ML DevSecOps, which is quite a mouthful. But this is ultimately how you sort of bring all these pieces together because you're servicing both the software requirement and the AI model architecture requirement. And so what I can actually do is I can just run you through a sort of a quick example that I prepared for a CI/CD pipeline. And so you can use your traditional tools, say sort of GitHub Actions, by which you're able to version your code, check that in, do the commits, go through the builds and the tests and the unit tests in terms of making sure your code is performing. And then again, using Snyk, you can go and do the DevSecOps piece where you're looking at the security and vulnerability assessments. And so again, you can use GitHub Actions by which you're able to then call out to Snyk and say, right, this is where I pass in my token. I want to just run the tests and get the results back in terms of what that vulnerability assessment or any dependencies I need to be aware of. And this also actually applies to how you can work with AI and ML models. So if you've got your model registries set up, then you can actually do the same with tooling that Advar uses. And in terms of that, you can set up your GitHub Actions by where you're able to call out to the robustness testing action, which is able to do adversarial tests autonomously. And one of the key things that you can do within this is you can define a threshold of performance. And the reason this is important because using the autonomous testing, you can stress the model to failure point. And by understanding that failure point and defining a threshold, you can then automate the option of deploying that model into your new software architecture. And so you've got effectively these different specialized steps where you're able to do targeted testing of the models, targeted testing of the security of the dependencies in the code, and then actual functional testing of the code pipeline. And what we tend to look at when we're doing this on the failure mode testing is we tend to use our labs to sort of help build up and make it so you can configure these containers and these testing APIs by which you can deploy. And so you can then do that with building up that architecture and then run that through the code pipelines and produce the outputs and do the automation. So it's all meant to be very intuitive and it's meant to be very integrated. And fundamentally, this actually builds on one of the key areas of MLOps, which is having a solid model registry. And there's many key reasons why this is important, but ultimately it allows you to control the versions of the models, understand the lineage and the governance of the data that's been trained, and also enable integration and deployment. So it's a key piece in understanding what's going on there. So what are some of the key takeaways I can leave you with? Well, first two, I'd say really try and understand the use case that you want to use AI for in your software architecture. Make sure that you choose the right model and actually really have a good think about if AI is the right solution at this time. You can then also do the same for model registries by where you can then manage the AI throughout its life cycle. But then the last two that I'll leave you with is that the key there is you can then integrate with CI/CD pipelines. You can automate your testing procedure. You can call out to those tests which allow you to evaluate specifically failure modes. And you should use different frameworks for their strengths. DevSecOps for security and MLOps for managing the model lifecycle. Anyway, thank you very much for your time, and I hope you have a good day.